For this video, we're looking at derivatives numerically. So let's suppose that you weren't actually given a function for f of x or for g of x, but you were given different values for these two functions and their derivatives. So at x equals 1, f is at a height of 4 and has a derivative of -2. At x equals 3, g of x is at a height of 5 and has a slope of 0. So you can see how to read the chart. So you might get asked different questions about derivatives of these functions. So let's say that j of x, a different function, is equal to g of f of x. So we have function composition. And someone said, what is j prime of 1? Well, what that means is that I have to find the function j prime of x, or find the derivative of j. So I'm going to say j prime of x equals, and I'm going to take the derivative of the right-hand side. You can see that this is composition of functions. I have an inside function. So this is the chain rule. So for the chain rule, I'm going to take the derivative of the outside function, leave my inside function alone, and then multiply by the chain, the derivative of the inside. So this will be g prime, leave the inside alone, times the derivative of the inside, f prime of x. Okay, so if I want to know j prime of 1, that will equal g prime of f of 1 times f prime of 1. So I'm going to start with the inside function and figure out what f of 1 is. So f of 1 is 4. So next, I know that this is g prime of 4. And f prime of 1 is -2. So my j prime of 1 will be whatever g prime of 4 is times -2. So g prime of 4 is -2 times a -2 is a +4. And that would be the answer. For the second example, we're going to find k prime of 4. Well, k of x is defined as f of 2 g of x. So this is also the chain rule, but I have a 2g of x on the inside. So first thing I'm going to do is figure out what is k prime of x. Well, it is the chain rule, so it's the derivative of the outside, f prime, leave your inside alone, 2g of x, times the derivative of the inside. Well, that will be 2g prime of x. So k prime of 4 will be f prime of 2g of 4 times 2g prime of 4. Well, g prime of 4 is a -2, so I know this will be a -2 times 2. This 2 right here. It'll be f prime of, and then g of 4 is -1, and I'm going to take that and multiply it by 2, so -2. So now I need f prime of -2. F prime of -2 is 1. So I know k prime of 4 will be 1 times 2 times -2, which is -4. So these are two examples of things you can do with the chain rule. For these two problems, I'm looking at the quotient rule. You can see that I have functions divided. So if I want m prime of 3 and I need to find m prime of x. So m prime of x will be the bottom function, g of x, times the derivative of the top, so f prime of x, minus the top function, f of x, times the derivative of the bottom, g prime of x, all over the bottom function, g of x squared. So if I'm trying to find m prime of 3, I'm going to find these values at x equals 3. So m prime of 3 will equal, first I'm going to find g of 3. Well, g of 3 from the table is 5 times f prime of 3. F prime of 3 is 3 minus f of 3. F of 3 is 1 times g prime of 3, which is 0. all over g of 3, which is 5 squared. So m prime of 3 will equal 15 minus 0 over 25. So 15 25ths, which reduces to 3/5. And that problem is finished. What if you have the quotient rule combined with some other function that's not given up in the table? That's really not a problem. So if you do s prime of x, it'll be the bottom function x cubed times the derivative of the top. Well, for this one, it'll be g prime of my negative 2x, but this is u substitution, so I need to multiply by the derivative of the inside, which is a negative 2, minus the top function, g of negative 2x, times the derivative of the bottom, that's just a 3x squared, all over the bottom function squared. So x to the third squared is x to the sixth. So if I want to find s prime of 1, I'm going to start plugging 1 in for all of my x's. So s prime of 1 will equal 1 cubed is 1. Then it's a negative 2 times 1, so I need g prime of negative 2. Well, g prime of negative 2 from the table is 3 times a negative 2. Minus, I'm putting in a 1, so I need g of negative 2, and that's just 2 from the table. So minus 2 times, I'm plugging in a 1 for my x, so times 3 over my x value, which is 1, to the 6th, which is just 1. So my s prime of 1 will equal 1 times 3 times negative 2 is negative 6, minus 6 divided by 1 is just negative 12. For the bottom two functions, we are looking at the product of two functions, and you can see that here. So we will be using the product rule. Now, I always include the negative number, a positive or negative coefficient, inside and in with your first function. So my first function for this will be a negative 2 f of x, and my second function will be a g of x. This coefficient of 4 will stay with my natural log of x, and then my second function will be an f of x. So if I'm looking for t prime of negative 2, I'm going to first find t prime of x, and that is my first function, negative 2 f of x, times the derivative of the second, g prime of x, plus my second function, g of x, times the derivative of my first function, which is a negative 2 f prime of x, and then to figure out where it is at negative 2, I'm going to plug negative 2 into all of these x's. So t prime of negative 2 will equal a negative 2, then I need f of negative 2, and I know that that is 2. And I need g prime of negative 2, and that's 3, plus g of negative 2, which is 2, times another negative 2, times f prime of negative 2 is 1. So t prime of negative 2 will equal negative 2 times 2 is a negative 4, times 3 is negative 12, and then 2 times negative 2 is a negative 4, times 1 is still negative 4, so minus 4 equals negative 16. For this next problem, my first function is 4 natural log of x. So b prime of x will be the first function, 4 natural log of x, times the derivative of the second, so times f prime of x, plus the second function, so I'm going to say plus f of x, times the derivative of the first. The derivative of 4 natural log of x is 4 times 1 over x, so times 4 over x. So if I want b prime of 4, I'm going to say it's 4 natural log of 4 times f prime of 4, and from the chart that is 6, plus f of 4, which f of 4 is 5, times 4 over 4, which is just 1. So my b prime of 4, this 6 combines with this 4 out here, is 24, the natural log times the natural log of 4 plus 5 times 1 is not 6, plus 5, and that problem is finished.